Here we have a related rates problem. So we're going to relate various rates of change in the problem. So the side length of a cube increases at a rate of 1/2 meters per second. So that's definitely a rate of change. So look at the units, meters per second, definitely a rate of change. Find the rate at which the volume of the cube is increasing or increases when the side of the cube is 4 meters. So this is not a rate. Look at the units, just meters, not a rate. But we are trying to find a rate. We're trying to find the rate of change of the volume. All right, so let's write out the volume of a cube. I know I'm supposed to draw and label a diagram. I'm not gonna draw a cube because I'm not the best artist, but just think about maybe a 6-sided die. Okay, that's a cube. So each of the length, width, and height are going to be equal. Maybe I'll use an x for the side length. So the volume ends up being x cubed. Okay, so then over here, what I'm going to do is I'm going to write out what I have and what I want. Okay, so what do I have? I have 1/2 meters per second. So that's the side of a cube is increasing. So if the side is increasing, I can notate that as dx dt. So it's increasing with respect to time because looking at the units, it's per second, meters per second. Okay, so dx dt is how I will notate that. And then another thing I'm given is a side length of 4 meters. So I can say x is equal to 4 meters. Now what do I want? I'm trying to find the rate at which the volume increases. So I want dv dt, the rate at which the volume is changing. Okay, and the units on that would end up being meters cubed per second because the unit on volume is meters cubed. All right, so then what I need to do is I need to take the derivative of both sides of my equation, v equals x cubed, with respect to t, with respect to time. So it'll be dv dt is equal to, now on the right side I'm technically using the chain rule. Derivative of the outside is 3x squared, and then I multiply by the derivative of the inside, which is dx dt. All right. So I'm already solved for dv dt, which is what I want. That's what I'm trying to find. So what I do at this point is I plug in what I have. So I'll plug in a 4 for the x and a 1/2 for the dx dt. Now if I multiply all that out, what I end up getting is 24. So that means the rate at which the volume of the cube increases is 24 meters cubed per second.